Hey, how's it going? And today we are taking a deep dive into the type macro. This is actually revisiting a tutorial I did earlier. What I wanted to do was kind of go over each of these examples in a little more depth, and I have them working in various configurations now. So before I didn't. If you copy and paste this, you're going to get an error. And so let's just talk about what a type macro is. So the type macro allows you to get the type of an expression, and it says it can be used anywhere a type can be used. A little further down it says verse has a special construct that can be used to get the type of an arbitrary expression. It can be used anywhere a type can be used. And you see there's a hyperlink here, but if you click on it, you'll notice it doesn't really go to any word construct. It just goes to where constructor is. So I'm not sure exactly what they mean by a construct versus a constructor, but in a certain way, I do feel like they're sort of related. I'm assuming that's because it has some similarities, and you'll see this in the code in just a minute here. So I just have a verse device in the scene. I have some other things, but this is all in the code. So let's take a look at this example here and show you. The first thing I wanted to do was just talk about what a type is first, because that word is used a lot and it can get very confusing. So what is a type? It's basically everything. Everything in verse is a type. So it sets the rules for what happens with different kinds of data. It controls the who, what, when, where of data. There is a type in verse called any, and it is the most general data type in verse, the superclass of them all. And type is actually a subtype of any. So it essentially represents any data type there is except for any, which is the superclass. And any doesn't really do anything because it's so general. Now the type macro is not the same as the data type called type. That gets really confusing, and I was confused about this because essentially you could be saying type type. Type is the second most general data type there is in verse, right underneath any. So you could just say you could just say type, I guess. But then you have the type macro, which is not the same thing. And the type macro can be distinguished from the data type called type by being next to curly braces. So if you see the word type next to curly braces, that's not the data type called type. That is the type macro. I made this in uppercase to highlight this term. It is a special construct, and I'm putting constructor because it has something in common with a constructor, and you're going to see that in just a minute here. Used to get the type of an arbitrary expression. Now that's an important word, arbitrary, because I take that to mean not yet defined or declared. Let's take a look at this now. What we have here is just a general function called main function. It doesn't take anything in, and it returns an integer. So inside this function, we have a print method that's going to print out this sentence here for 10 seconds. And then it's also going to return this integer value 777. Vanilla function, not doing anything that particularly special. Down here, what we do is we're creating a new function, and I'm calling this typed function because it's essentially built off of a type. Here we're using the type macro here, right? Which you'll notice mirrors how this is set up here, right? So it's type macro, and we can't call this part here main function because we're going to get an arrow. It's going to be ambiguous. But then essentially what we do is it's almost as if we initialize it with this function here. So it looks like this is the body of the function, but in a sense this is operating a lot like an initializer with this type retrieving, mirroring, or constructing, or however you want to say it, especially constructing this main function. Because what we end up with when we do it this way, when we use this type macro, and then we reference this main function that we've created, what we end up with is basically a carbon copy of the main function. I don't want to use the word instance, but we create almost a duplicate of this function here. So if we come down here now, and I call type function, and remember it's parameterless, if I call it, right, the return is an integer, right? So this essentially is mirroring this main function, but it's not the main function. It's called type function. So it's a separate function that basically has the functionality or the type of the main function. And now the return value is 777. So that's what we get out. The output of main function is whatever main function can do, type function can do, because of this special construct we have here, which essentially gets the type of the function. And I'll be back in just a minute with the second example. For this second example of the type macro, we're looking at this function here. And honestly, I struggled with getting this to work initially. And it says that this example also makes special use of this identifier here, the underscore, which can be used in type in places where an identifier is expected without having to actually provide a name. You'll see this around from time to time. It's good to know what that is, that underscore. So let's just take a look at this in the code then. In the scene, I just have the verse device, and I have some new code in here now. So we have our enumerator here, and what I discovered in doing this is that we needed to add the transact specifier to these methods or functions down here. Well, we have our enum up here first, and then we, straight out of the code, straight out of the example, and then we created a tuple with two integers in it, 10 and 2. And then what we do is we call this function, which takes in the enumerator. So we're going to be calling the greater than operation here. So we go comparison.gt, and that comes in here. And then what's interesting is what this outputs. And essentially what it does is it outputs the results of a function as another function. This pattern here, again, is the same as this pattern here. You'll notice that that's common with the type macro, is that the overall structure of the function has to match. Even though it can go extract the type, 2 values in and 1 value out, we need to have 2 values in and 1 value out to match. Everything needs to kind of line up. We call down here to the function with the enumerator, and then what this returns is a function. It returns a new function. It actually returns the greater than function. When we go to call this, though, because this uses a comparable operator, a comparable operator, we can't just call it. We have to call it as a failable expression. So this new function now is actually this right here. So it's kind of slick how this works. So this new function is now the greater than function here. So we can call it with 2 values. It requires a tuple in. So that's why we created this tuple up here, right? And it's a failable expression because this may not succeed when we call it, right? So it's a failable expression. So we call it with my tuple. It's in the brackets, just like we would normally call a failable expression. And if it succeeds, if the values that we send in, if 10 is greater than 2, if x is greater than y, then this succeeds and it'll print out the value. But if we were to send in 2 values that this isn't going to be true, then it's going to fail and we're going to get this else statement here. Let's go ahead and compile and save this. What should happen is when I run the program, you should see the value is 10 because 10 is greater than 2. So let's go ahead and see if that's what we see. And let's just be on the screen for a second. The value is 10. That's correct. Okay. So now let's just go in here real fast and change those values. So let's change this just to swap them around. 2 versus 10 or 19. And let's go ahead and compile and save that. And this is going to fail. So let's go ahead and do that. And just push those changes real quick and see what this looks like. Okay, so let's see. So this should fail, so we're going to see the else statement. The expression failed. That's correct. I wanted to do this just because I found it kind of difficult to get through that example of what the type macro is. So from here, we can keep expanding out and learning. But anyway, I hope you found it helpful. Take care. Have a great day, and I'll talk to you next time.